We're going to talk today about rational versus irrational numbers. They are a part of the bigger system of the real number system that we'll get into more later. You'll see that the real number system is made up of rational numbers and irrational numbers. Those are big sections. And then rational numbers are further broken down into more specific terms that we'll explore more in the unit. So first thing you need to know is that rational number actually starts with the base word of ratio. And these are numbers that can be written as a ratio of two integers. Or an easier way to say it is they can be written as a fraction. We write that as an A over B, where B cannot be 0. Obviously, if we write a number and we put a 0 under it, when we go to divide, that's an undefined number. So this can be any number that can be written as a ratio of two integers. Remember, ratio means fraction or comparison of two numbers. So irrational, on the other hand, are numbers that cannot be written as the ratio of two integers. So you cannot write them as a fraction. So let's explore a little bit more what that means. Let's look at some examples. So let's say we have the number 1/3. 1/3 is written as a fraction. It also can be written as a decimal, 0.3 repeating. Notice that decimals are part of rational numbers as well, but they have a little bit of difference. They have to have a pattern, or they continue, like 1/3 continues forever. It has that pattern. It doesn't terminate, but it has a pattern. Or it ends, like for example, 3/4 is a fraction. If we write it as a decimal, it's 0.75. It terminates. It ends. So these are rational numbers. 4 is a rational number because I can write it as a fraction. I can put it over 1. 2/5 is a rational number. Again, I can write it as a fraction, and if I wanted to, I could change it to a decimal, and that decimal would have a distinct pattern. What about, let's say, 18%? We can write that as also a fraction or a decimal that terminates. That's the same as 1800ths, and it terminates. It has a definite end to it. We may think of negative numbers. Well, let's say -2. Well, -2 is also rational because I can write it as a fraction by just putting 1 under it. One that gets people sometimes is 0. 0 is a rational number. I can write it as a fraction. I can put anything under it. A 1, a 2, a 3, a -20. It's still going to be 0. So these are all examples of rational numbers. The ones you may not know as well is irrational, and the one that's most common is pi. Pi is one of those numbers that goes on forever and ever. 3.1419, we can keep going on forever. It has no distinct pattern. So the thing that you have to remember about irrational, think about when someone acts kind of unrealistic about something, or they kind of go off the deep end. They just kind of act weird. You don't know what's coming next. They have no pattern to them. They just go on and on about something. They're very irrational. So irrational numbers are that way. They don't follow a plan. They do their own thing. So this would be something like non-repeating decimals. So if we have something that goes like 0.321328, it just keeps going. There's no pattern to it. So non-repeating decimals. And you also have non-terminating. Means they do not end. And that's an example of pi. Non-terminating. So think of this as no pattern. They're very irrational. They kind of do their own thing. So we have to remember that pi is a very good example of this. Other numbers that we might see are non-perfect roots. And we'll get into perfect squares and cube roots, but non-perfect roots are also irrational. So if we have something like the square root of 2, that's a non-perfect square. It's a non-perfect root. That would be irrational. When you put these in your calculator, you'll see that the calculator, when we learned how to change numbers on a calculator to fractions, if you put in a irrational number and try to change it to a fraction, it will not work. The calculator will not do it. It will give you the same number over and over because in the calculator has no pattern. It continues to go. We only see what's on the screen. So you're going to do some activities where you're classifying rational and irrational numbers, and you'll learn more and more about the number system as we move forward.